For one thing, it's really good, helpful for approximating some integrals. There are certain integrals that we can't evaluate with any of our techniques, U substitution, the various techniques. Then also, it's just helpful to simplify. These power series, they put it in more basic terms because a power series is just powers of x, basically. I mean, you've got other stuff involved, but more or less you get it down to powers of x. And so that's why we take off in this section. We're going to talk about representing functions as power series. Now the first one, this is a very important one to understand. You've got to understand this one because this one leads us into basically all of them. Let's look at our most basic power series. And we're going to run that 0 to infinity. This is one we started off with power series, and now we're coming back to it here. What does that become? Or what is the interval of convergence there, and why? The interval of convergence here, remember, was -1 to +1. And how come that was that? Why was that? Because really, what does this power series represent? It's just a basic geometric series, right? These are the geometric series. X to the 1, x to whatever x is, you've got yourselves a geometric series. And so that's going to converge when that x is the ratio. R. Right? You with me? Okay. Well, we're going to take this one step further now. Okay? So if our ratio is between -1 and +1, we have convergence. But we can go one better. Because on geometric series, we know that this series, if we have a geometric series, we know the sum of the series. What is the sum of this series? Isn't it first term divided by 1 minus the ratio? What is the first term? Well, n equals 0. We have x to the 0. It doesn't matter what x is because that's 1. All right, what's my ratio? Aha. This right here is what we're after. It has a radius of convergent. What this is saying is whatever your x is here, on out to infinity. If you have a function that looks like this, 1 plus x squared plus x cubed plus x to the 4th, whatever x is, to add up all those terms, all you have to do is 1 over 1 minus x. Well, isn't this kind of looking like a polynomial sort of thing? So this is taking an infinitely long polynomial, and we're writing it only as 1 over 1 minus x. So it shrinks all these terms, if you will, down to this. Now, the only thing is, this only works for certain x's, right? What x's does it work for? It only works for those, right? So if you get x's out at 1 and anything bigger than 1 or anything less than -1, well, that's not going to work. But as long as the x's are between 1 and -1, all these terms go to this. Okay? All right. Which is our interval there of convergence. Okay. So this is what we need to remember. Because here's what we're going to do. What we're going to do is we're going to try to take, in basic form here, we're going to try to take something that resembles more or less something like this, and we're going to try to write it as a power series. That's what we're going to try to do. Sound like fun? Okay, write 1 over 1 plus x squared as a power series. Kind of looking at it the other way here. Now that's not too terribly complicated, but we want to write it as a power series. Let me move this. Okay, so we know this. All right, well, I need to write this then as a power series. Well, of course, I don't have exactly a match there, but take a look at this. Couldn't we say 1 over 1 plus x squared is 1? How about we say it's minus x squared? 1 over 1 minus x squared. Why would I do that? Well, I would do that because then I have pretty much a one-to-one correspondence there, don't I, for my power series? Since 1 over 1 minus x equals the series x to the n, what do you think 1 minus x squared would be? Well, it'll be n equals 0. Well, I just replace, since that minus x squared has replaced x, I replace x by minus x squared right there too. Which is pretty much it. Let's clean it up a little bit. Couldn't I say that's n equals 0? Let's say it's minus 1 to the n, x to the 2n. For whatever reason, they'll prefer, I guess, that format. Like that way, all right? Either way. But the only reason, maybe one of the reasons for doing that is for future purposes. If we have other stuff with that, we can combine things. And so that's why they're breaking it out probably like that. Okay? Why I'd want to. All right. Now, one other thing to think about. Did my interval of convergence change for that? What's the interval of convergence for this? Well, the interval of convergence over here is, I can write it that way, another thing to remember. Its interval of convergence is the absolute value of x has to be less than 1. Well, what have I done here? I've replaced x by minus x squared, so let's do that in our interval of convergence. I now know minus x squared absolute value has to be less than 1. Well, the absolute value takes care of the minus, and x squared is always positive. So I just have to have x squared less than 1. We've seen that before. What does that mean? Same thing, isn't it? Doesn't x have to be between negative 1 and positive 1 for that to work? So it's the same interval of convergence. That one didn't change. It sometimes will change, so just be aware. Okay, let's try another one. Is that okay? I'll leave that up here. All right, what about find a power series representation of one over x plus 2. Well, we have a little more work to do on this one. My goal is to have, like I had before, I need to have it in this format, but it needs to be more like that. And you see the problem here is, well, one thing, I've got the x let's switch the x over here. But this right here, well, all right, so switch those over. One thing that we had previously on the previous problem is that was 1. I have the plus here, so I'm going to have to do the negative thing again. But the other problem here is this is 2, not 1. How am I going to fix that? Well, I need to factor off a 2 here. Let's factor off a 2. Now, there's not a 2 to factor off over here, so what does that make it? Yeah, x over 2. Because when you factor off a 2, you're dividing by 2. So that makes it a 1. So I don't have a 2 to divide off there, so I just have to recognize that and say it's x over 2. All right. Now, what I can do then is this. Break off that 1/2. So it's 1/2 times that. And this, now, I can do my negative thing. Which I now can represent that. With me? Now I can represent that as my power series. Now I have this extra 1/2, so it comes along for the right. So that'll be 1/2 times the power series here now is n equals 0 to infinity. What's x? X is minus x over 2. Substitute that in for x. Okay, but yeah, let's clean it up. So it'd be 1/2. And the n equals 0 to infinity. Let's just break all those up. -1 to the n, x to the n, over 2 to the n. Now, is there anything wrong with bringing that one in? No. That can go in inside the summation. And won't it combine nicely with that 2 to the n? what would that be? What would this times that be? Be negative 1 to x to the n, negative 1 to the n, x to the n over 2 to the n plus 1, because that's 2 to the 1, so when you multiply those, you add the exponents. And again, for whatever reason, they usually will split out the x part by itself. Is that necessary? No, but it's just what they do. Okay? Now, again, it's always important to know your interval of convergence. What do you got? Interval of convergence? Well, this one starts with absolute value of x is less than 1. I replaced x by minus x over 2, didn't I? So what does that make my absolute interval of convergence? Well, the absolute values will take care of the negative, so it'll just be just the absolute value of x is over 2 less than 1. Multiply by 2, because I can split out that the absolute values, and it's just that, right? Because the absolute value of 2 is 2. Just multiply by 2. So the absolute value of x is less than 2. So my interval of convergence is negative 2 to positive 2. Yeah. We're negative. I guess they are writing an interval notation there. Okay? Is that all right? How about one more? Up for one more? Okay. Is okay? All right. Okay. Find the power series representation of x cubed over 2x plus 1. Yeah, we're progressively getting harder here, aren't we? Okay, well, what I know I can turn into a power series needs to vaguely look something like that. Well, the top needs to be 1, so let's factor off the x cubed out front here. Let's flip that around. Easy enough. So it's 1 over 1 plus 2x. So we need our negative trick there. X cubed, so that's 1 over 1 negative 2x. So far, so good. So now this I can represent as a power series using that. So it would be x cubed times the power series would be n equals 0 to infinity. X now is negative 2x to the n. Which is, again, let's do our little breakdown here. That would be negative 2 to the n, or maybe even negative 1 to the n, times 2 to the n, times x to the n. Break it all down. They may leave the negative 2 together, but anyway. All right. Now, we can go ahead and bring this back in. Yeah, that. No reason why we can't do that, right? If we bring it in, what can I do with it? Yeah, I can combine the x to the 3, x to the n, can I? What would that be? X to the n plus 3. So I have the series n equals 0 to infinity, negative 1 to the n, 2 to the n, x to the n plus 3. Okay. So this represented by that. One other little note there. What about the interval of convergence? Well, again, starts out with the absolute value of x is less than 1. I did a negative 2x for my absolute value for my x. So it's this, which take care of the negatives, bring out the 2, just divide by 2. So it goes from negative 1/2 to positive 1/2. That's my interval of convergence. All right, now, again, what we're saying then is this right here can be, let's write it out, represented by this right here. So x cubed over 2x plus 1 equals, for this range right here, it's a small range, but for that range it equals this n equals 0 to infinity, negative 1 to the n times 2 to the n, x to the n plus 3. What that means is this expression can be represented by, let's plug in a few, negative 1 to the 0, 2 to the 0, those are both 1. X to the 0 plus 3, so it'll be x cubed. That's my first term. My second term, negative 1, so it'll be a minus. 2 to the 1 will be 2, x to the 4th. Then the next one will be n equal 2, so it'll be a positive 1, 2 to the 4th, so 2 squared will be 4, and then x to the 5th. Then the next one will be minus, I'm going to say it's minus 8, x to the 6th, plus